Let's go back to actual proofs by contradiction. This is going to be a real honest-to-God result, and but it's going to be something a little outside of number theory. I wanted to focus mostly on number theory stuff because that's the course I'm setting up. But here's one from trig. And so here's the thing. For all theta, you want to think of that as an angle with 0 less than or equal to theta less than or equal to pi over 2. The claim is that cosine theta plus sine theta is greater than or equal to 1. Now, notice that cosine theta itself can't ever be greater than 1. It can only be equal to 1 in very, very special cases. And sine theta itself can't be bigger than 1. And so it's not just, oh, they're both bigger than 1, therefore the sum is bigger than 1. It's that that even though these things are between 0 and 1, their sum is bigger than 1. One way we could say this that's a little tighter, if we want to practice our mathematical notation, this idea of whenever you have a universal for all some things, some variable usually, you usually want to say where it is, what kind of thing it is. Well, it's a real number. I didn't say that explicitly, but this makes it pretty clear. And this makes it, in our sort of standard form, theta is in the set of real numbers from 0 to pi over 2 inclusive. So you could say that instead of this. Okay, it's a little tighter. Okay, so one thing to notice is that these restrictions say that, as I just said, that cosine theta and sine theta are between 0 and 1. Okay, so I just want to put that out there as a result of that restriction. Okay. Actually, before I want to go into the depths of the proof and actually sort of start the proof by contradiction, I want to give this a geometric flavor. Usually, I want to think of trig as circle trig, living on the circle, because that can be that's more flexible. Now, with theta between 0 and pi over 2, this is radians, of course, then I don't absolutely have to do that. But I'm looking at this part of the circle, and remember that the cosine, so this is the unit circle, say, the cosine of an angle, theta, if theta is here, then the cosine is the x-coordinate, and the sine is the y-coordinate. So I'm saying that this has if this has coordinates x plus xy on the unit circle, that x plus y is greater than or equal to 1. Well, x plus y equals 1 is the line like this. Okay, and greater than or equal to 1 is where x and y are bigger in aggregate. And so it's saying that this part of the circle is outside of, is up and to the right of that line. Geometrically really obvious. So again, I'm not focusing on things where it's really stunningly new to prove some of these things, because that's not what I'm trying to get at here. I'm trying to get at the basic technique. So this is something we should believe intuitively, but how would you prove that really carefully using something as, you know, sort of more algebraic than just say, hey, looks, the picture seems to confirm it. I mean, did I draw the circle correctly? Yeah, I did, but, or, you know, qualitatively so. So let's look at it, okay? So let's start the proof by contradiction. We're going to use this to just 2 s's in assume. Okay, I'm going to assume that cosine theta plus sine theta is less than 1. Okay, what does that buy me? Well, I get to manipulate that. It's a distinct inequality. I get to manipulate it. And the thing is, I really need to use the basic geometry of that unit circle. Or equivalently, we could talk about Pythagoras. So I'm going to square both sides. Okay, and so if I multiply this by itself, or I multiply 1 by itself, 1 squared is just 1. So the square is also less than 1. So let me expand that out. The reason you would do that is 2/3 of it is something, oops, that is really, really nice. Very common from trig identities that you, even if it's not there to begin with, you want to figure out, engineer a way to get the Pythagorean identity into there. Okay, so that is less than 1. Hey, wait a minute, that is 1. So we're saying 1 plus 2 sine theta cosine theta is less than 1. Kill those, that's going to be 0. So we're saying 2 times sine theta cosine theta is negative. That's our contradiction, because we know that in this quadrant, cosine theta and sine theta are both positive. or non-negative anyway. So there's no way to take two non-negative numbers and multiply them together and double it and get a negative number. So there's our contradiction. Because we've reached our contradiction just based on assuming the negation of what we want to prove, we're good. Again, wouldn't be a bad idea to say, because we've reached a contradiction, that shows that, and then we could just reiterate the original conclusion we wanted to get to. Okay. So there's something where we had to know a little bit more. We had to know about trig, we had to know the Pythagorean identity, do a little algebra, but it gives us a very tight and algebraic proof of this fact that cosine theta plus sine theta is greater than or equal to 1. Oh, one thing I also forgot to mention. You look at the graphs, like as functions of theta. Here's sine going up like that. Here's cosine going down. One of them is going up as the other one goes down. So yeah, it's plausible that they're always going to be above some minimum value. But what is exactly that minimum value that the sum of these two guys is always above? Well, it's always greater than or equal to 1.